Our next presenter is Mr. Ben Foster from the Maine DOT. He's representing the Northeast Bridge Preservation Partnership.
My presentation's a little bit different than the first two you saw. It's more of a panel discussion, so I've learned from my boss to delegate. So I'm going to delegate some of the time to the audience. And because this is all about network and learning about what each other does. Many of us, we're the structural resource for the whole department. So not only do we look at bridges, we have to look at ancillary structures, retaining walls, and whatnot throughout the department. So in the Northeast, we decided to, hey, let's start with retaining walls and start the discussion there. I'm going to have about a 10-minute presentation, show you things that, problems we've had with some, and fixes, and then we'll open it up. Here are metal bin walls. It was used in the 70s and the 80s. Many near railroad structures, as you see here. They're designed in a cellular construction. They're basically a metal box. The metal is galvanized. You fill those boxes, and then its self-weight holds itself up. The thing about these is that it deteriorates from the back of the wall to the front. All right, and that happens because when it backfills, some of the rocks that get in there knock off the galvanization. The water gets to it, and it rusts from the back to forward. So by the time you see it, you already have a problem. Okay, this just shows some of the cellular construction we got going on. Just gives you an example of what it looks like. And here's the problem. If you look at this, we have inspection poker rods. You're able to ram it right through. This wall here is about 20 feet high. It's running into problems. So the first thing we tried was the Band-Aid approach. Up in the top left of it, you see a steel plate, which was, I believe, pop riveted to the steel because there was a place of minor deterioration. Well, that works, but as you can see, the deterioration on the wall is far more expansive than what you see there. And it worked good for that about 3-inch area right there. So we went from the strawberry shortcake Band-Aid to the whole bandage, where we are welding steel sheets to the wall to basically to prevent the fill and to protect the road from coming all the way out there, and this one's onto the railroad tracks. And this right here is a temporary fix. This is probably only going to last 3-4 years until we can get some type of replacement for that wall. And it's in many locations. There are other repair options. I've seen some online. We have a document that give a few. You can soil nail, basically drive your soil nail in front of that metal wall and put a steel grid on the outside and shotcrete it. You can drive sheet piles in front of it, or you can replace it with an MSE wall or other type of wall system. Okay, and here's MSE walls. Here's another type of wall. These here are precast panels, and you can either have a metal strap that ties back and the weight of the earth holds those panels in place, or you can use, I've seen a plastic mesh going back. In Maine, we do not allow the plastic mesh. We just allow a galvanized strap. But these also have problems. Okay, you look in the center of this wall here, the darker locations. When you get water, is allowed to, is not taken care of up above and gets down in here. This wall here started to bulge. Next thing you know, you had a little hole. We gotta take care of this type of stuff. You can see the metal strap sticking out of the wall there. What happened here is that the water got down there, deteriorated those straps, and now those precast concrete panels just came off. So we got to take care of the water up above. So the decision was a soil nail system. They drove some rods in there, basically shotcreted the edge, and that was called good enough. This was another state that came up with this. You can notice that they also soil nailed some of the other precast panels outside the failure zone just to stabilize the area. Okay, there was another failure, something very similar. Okay, here, this actually shows the straps that have corroded, and you can't see those straps. I mean, I run the bridge inspection program, and you don't know what you can't see, and that's the case with both these wall systems. So this was a little more substantial fix here. They decided to take it all out in a V-section, basically use a grid and fold it over itself and have its own system there. Then they'll attach the precast panels onto this. So here are some of the questions that have come up in Maine. Just what are the problems and concerns with these wall systems, not just MSE, but other ones? What's the projected lifespan? You know, when you design them, you assume a little bit more corrosion, but you can't really tell. You're not sure until it starts bulging, and once you start bulging, then you're in panic mode. Steps that are taken to protect steel straps. Do you put a barrier over the top of them? We put some type of sheet so the water doesn't get down into those. And you also have differential settlement. You know, granted, the geotech has designed it and so forth, but you have situations where, you know, you got a clay deposit here that you didn't anticipate, and that settles where the other doesn't. So that's all my point. Now we're going to open it up to a panel discussion.
Yeah, I got a question with you in trying to understand some of this problem over here.
Yep.
In Florida, we don't have this issue, but we do use plastic straps in salt water. What it looks like is happening over there is that you use a certain amount of de-icing chemicals and road salts, and somehow they're getting through the roadway down to the galvanizing where you're getting enough air and water to cause some corrosion down there. You might have a few nicks on the galvanizing, and it looks like possibly that's what's going on. Is that the way you see it too?
I agree. Where the state that this happened in, they do not have a barrier on top. So the water and the chlorides, it's the Northeast, so you are using chlorides. It is getting down in there and deteriorating. Even those straps are galvanized, but with a backfill process, very similar to bin walls, the galvanization gets knocked off, and that's what I think is going on.
It would seem to me like, and I really don't know exactly what happens with the hydrology in the soil over here, but if you could create some type of barrier to somehow prevent that, like a pond barrier on top of that, and maybe extend that out to kind of concentrate your drainage into the embankment more towards the center roadway, away from the straps, you might be able to buy a little bit more time.
Yeah, I agree.
In general, though, your chloride's seeping through the soil because the soil has a free ion. It sucks up a lot of the salts. So I don't think it's just the chlorides that we're having an issue with. I think it's constructability that, you know, you're taking something galvanized, whether your bin walls or your straps, and you're just banging rocks on them and you're violating it. You know, and galvanized products are really good, but they can only take so much abuse.
Yep.
Question, so because of the chloride and potentially corrosive soil issues, do you ever consider having like bulk galvanic anodes like magnesium or something embedded behind the wall to help provide more sacrificial metal to protect it for longer?
That could work. We haven't done that in Maine. Has any other states used that technique? I'm going to take that as a no. I would say it's a possible option. When I was talking to the maintenance engineer from that state, they said the water ponded right over the top, so they got a lot of hydrostatic pressure, and more of the water got down there and deteriorated. But
I have a question. How many, with a show of hands, how many other states have asset management plans for retaining walls? Few.
I think Oregon sent
something out.
something
Asset
out.
management plans for the bridges. Everybody raise a hand. You know, retaining walls kind of taking a back seat to this, and And I guess it was the bin walls that really showcased this, and
Yeah.
we really don't know what we've got, the condition and all that, so we're just in the infancy of developing an asset management plan for them.
In Illinois, we use epoxy coating on the straps, but honestly, we're not that deep into MSE walls, maybe 10, 15 years, so I don't know if in 10 or 15 more years we're going to have the same problems. I also have some concerns because we're building abutments now where we put the piling in and then we wrap them with an MSE wall abutment. Am I going to lose my approaches because the MSE wall has failed?
I hope not, but yeah, I would have the same concern with the epoxy coating as I would the galvanization as far as stuff getting knocked out as when you backfill. But it's just a concern. If you get rid of that water, that way the chlorides and everything gets down there, I would strongly recommend that.
What's the time frame, do you know, that when that bridge was built, or not the bridge, but the retaining wall, and where the MSC had the problems?
I believe it was about 30 years.
Okay, yeah, that's kind of scary.
I just have a question. It seems to me that if your straps are corroding, it will be either the water or the salt penetration on that, or perhaps, the pH. I don't know what your construction standards are. But you mentioned something that caught my attention. If you're having problems with corrosion on the straps, what is the reason why you said that you guys are not using synthetic reinforcement?
I guess I'd have to talk to the spec person.
I mean, that's typically a wall manufacturer. I mean, just designing the wall. I mean, MSC walls, and most of these walls are designed by the manufacturer, the straps and the...
Yeah, in the spec in Maine, we choose not to. I'll have to go back and talk to my geotechnical compadres.
No other question. How about anybody get a solution? What are your solutions? That's what we're looking for. We know we've got a problem out there. We don't know how big. We'll find that out. Now we want solutions.
Who's got the metal bin walls? I want to know that. And do they anybody else? Only one state? I've driven through others and seen them, so I know.
You asked about differential settlement, and I've used a MSC wall with square panels, not the interlocking panels, but
Yep.
they have vertical joints, so that's one idea.
Yeah, if you look at the left joint here, that's our vertical joint, and I know you can't see it's moving. The ones just to the inside, more towards the bridge, are on the footing, and the other ones are not, so that's an extreme case. We preloaded this sucker for 6 months, put somebody out of business, and it still didn't work. So,
Did we have a show of hands on metal bin walls? Who have metal bin walls? What's the number?
are you seeing the same problems that we're seeing here as far as corrosion, just because it's from the backside forward? All right, maybe it's just the northeast that has them.
I'm just curious as to how old the walls are that you're seeing these failures at. 'Cause
Yeah, there's
probably
70s
20
and
years.
80s, so they're about 30 to 40 years old. And some of them, as you can see with the bandage approach, it was pretty extensive that we had to put something on there.
Unfortunately, some of those bridges that, with those MSE walls, I actually designed 30, 35 years ago, so,
I wasn't going to mention that, but
yeah. Well, now I have the pleasure of fixing them.
Jeff, I think you're getting beat over here.
No,
by
no,
John.
I'm one up on him already.
You're looking for solutions. I think I just have some ideas
Yep.
to throw out there. I think before you experience the wall failures, then you could proactively do a testing program, take some soil samples to see how contaminated the soil is with chlorides or the pH of the soil, and see if that is going to be a problem in the next 5 to 10 years. And then if you find locations that do have contamination, you can institute some kind of a program to either change the properties of the soil or do some kind of in situ grouting of the soil, or just kind of replace it, mix it with other materials.
Yeah, we got a moratorium on these now because of what's going on, and I think by the time I think every single one we have out there has the same problem. So
Yeah,
I
the
think
solution
we're-
for the bin wells is to replace them all.
Yeah.
If you're looking for a solution, I mean, it's money, right?
Yeah. I mean, everybody in here has a limited budget. I'd like to have the $2 billion that Florida has. That could do some. That could do some stuff.
But I mean, if you're putting a MSE wall, you're wrapping an abutment, or MSE wall around an abutment, that MSE wall needs to have a 200-year design life, because you sure do not want to go in and repair it. Because the bridge is going to need to be supported, shored, whatever. So if the bridge has a 100-year design life, and you are going to want to at least get 2 bridges out of the life of your MSE wall. So the solution is money.
Right.
Instead of using 1/8-inch straps that are 2 inches wide, you use 3/8-inch straps that are 4 inches wide.
Right.
So
You
that-
over-design the.
Yeah, I mean, or you do go to the plastic rods, carbon fiber rods, whatever it is. The solution is money, and the solution is designing the 250-year design life out of it, 200-year design life out of it, so that you don't have to go in and repair it. So it's just money and time.
That's all. I mean, that's what my kids tell me. Dad, it's just money.
I will show you a note in this picture here that we found out that if you know it's a failure is only where those sheets are. In that bottom area, there isn't a failure. I had some thoughts that there might be just a different fill material in the bottom. Might be just common borrow in the bottom and a gravel in the top. I really don't know. We really don't. But it's pretty surprising why it's only in that top area.
That's pretty consistent.
Good presentation, thank you. Part of me is thinking enhancing the waterproofing system from behind, like a membrane, might be part of the answer, like a Band-Aid. To rechannel the water mostly.
Yeah, you talking at design?
Even repairs.
Well, we'd have to dig this whole sucker up to get there. So, if you're going to do that, you're going to put a new wall in. So,
we have problems with MSE walls in Kansas, different, but multiple different problems that we're having with MSE walls. We use select backfill in order to let the water drain all the way through, but we end up losing all the fines, and our approach slabs settle, our pavements settle, and it's half a dozen one way and 6 the other. If you're handling the water up above, it's not gonna stay. Eventually, it's gonna fail, that water handling system. If you let it go down through, eventually your fines are going to come out through the joints, and you're going to have settlement, and you're going to have to do repairs anyway. Our area repairs, they go in there and mud jack the approach slabs, and that locks all that aggregate together and doesn't make it free draining anymore. So then that introduces, it's just.
Hold on, you said mud jack. What's that?
Mud jack?
Yeah, that sounds cool.
They core down through and put
pump grout in there
in order to lift those approach slabs back up, and they fill all that select aggregate backfill that we paid the pretty penny for with flowable fill. So
okay, cool.
Oh yeah.
John Taylor of USL. The gentleman here mentioned waterproofing behind the wall.
Yeah.
Has anybody thought of curtain grouting using chemical foams and such? We provide curtain grouting, for example, to waterproof manholes from the outside without disruption, in a no-dig situation. And it seems to me, I'm not familiar with these walls, but it seems to me that might be a solution, that we can inject grout and curtain grout from the outside. I don't know if anybody's come across that.
Has anybody curtain grouted?
It seems to me a perfect solution to waterproof behind that wall without digging the road out.
So Ben, I think most of the conversation has been around water.
Yeah.
And trying to figure out what to do with the water. I mean, the water has a lot of factors in causing these failures. And I don't think you can fight water very easily.
Well, no, Graham just showed you it's pretty tough.
Yeah. So, the idea of letting the water out, letting it flow everywhere, channel it to the right spots has been tried for years behind the wall. So I guess I'd just throw out the idea of using something like a maintainable drain, through the front of the wall. So it's something, we looked at earlier this morning, but,
Right.
if you think about it, letting the water flow freely all the time and getting it out of there and being able to maintain it.
All right, thank you, Ben. Great presentation.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.